Thank you. Thank you. It is a delight to be here at Tech Mecca, talking with you all about this very important question. A question that is simple, huge, soulful, strictly scientific, techie, meaning of life size. And it's a question that we ignore, shirk, skirt, ridicule, and pretend we've answered when we haven't. An old family friend and I were catching up with each other, and he asked me what I've been up to, and I described the question to him. And he balked in a telling way. He said, it sounds like you got way too much time on your hands. It's way over my pay scale. It's a question that can never be answered. And it was answered last week in a Facebook post about quantum consciousness. So I got all four of them from him at once. It is a simple question, much simpler than any of the things that you deal with. And yet it is a fairly unfamiliar question. People do tend to balk at this question. So the way I'm going to do this is I'm going to frame the question and then pause for challenges, kick the tires on this thing, really try to get clear on the question, challenges, questions, all of that, and then give you a new proposed answer, which is unlike anything I've seen from other sources. The question is, what are striving selves? I strive, therefore I am. You know, Descartes said, I think, therefore I am. I'm going to go much deeper than that. I strive. I try. I make effort. This doesn't make effort. Computers don't actually make effort. They do work. They do very useful work, but they don't make effort. They are not striving. And I'll be more specific about that in a minute. But you can call us any number of things, an agent, organism, living being, and I'm just going to call us selves, and I'm going to call us all selves. That every one of these organisms is striving. It is doing work for its own benefit. Striving means not going with the flow. And you can see that here in this self, going upstream, and it's more than this. It's more than just going upstream, because really what's going on is we are going against the flow towards degeneration. Everything falling towards entropy, randomness, disorder, falling apart and petering out. So very simple, straightforward question. We don't. We run to stay in place like the Red Queen in Alice Through the Looking Glass. And it's happening right now unconsciously and unfelt, striving like what our bodies are doing right now. Right now, my body is regenerating itself faster than it degenerates, and it's doing it without me understanding what it's doing, without any awareness of it, just like it does in bacteria. That is, they don't have consciousness, they don't have feelings, and yet they are striving against the tendency to degenerate. So really, we can distinguish between two kinds of things: the things that exist, lasting as they degenerate, depending on their durability, and selves, which persist, striving to regenerate. Very big difference, as yet unexplained by the sciences. That's the question. And as I said, machines are not striving selves. We engineer them for durability. Computers aren't striving selves, and striving selves are not computers. I adore computers. I live on them. I spend most of my time on them. This is not a Luddite talking. I'm not protesting against the use of computers as though they are heartless. No, I think they're full of heart, the way I use them. But they are not striving. So the question comes down to this. There's no magic added, and yet selves are means to end striving, not just cause and effect mechanism. There's something different about us from nothing but chemistry. So I rule out from the start the idea that there's some magic non-thing thingy that gets deposited into matter that makes us come alive, a soul, a spirit, a vital force, or any of that. None of that will work, nor will the argument that there's something about all interactions, all material interactions, all cause-effect that's actually a little bit means to ends, and you collect enough of that up together, and suddenly, poof, poof, it's suddenly a striving self. No, I'm ruling all of that out. And also, I'm ruling out the argument that all we are is cause and effect mechanism, which really does corner us with a challenge. What are striving selves? There's a fundamental gap in our research. Scientific research. Striving selves are inadmissible in the physical sciences. If you had a physics professor who told you that the moon strives to pull on the tides for someone's benefit, you'd think there's something wrong. But down the hall, you've got a biologist or a social scientist who can talk all they want about striving selves. So there's this fundamental rift. Take these three terms, absolutely essential in biology. You cannot do biology without basically function, fittedness, and striving. That's about selves. That's about selves engaging in what I'll call self-directed work, effort by selves for themselves, responsive to their circumstances. Now, the way it works for continuity in the sciences is that the lower level scientists have to explain what the higher sciences assume. And we got a huge gap here. As chemistry does not explain functional fitted striving, and yet we totally rely on it in the life and social sciences. So the approach I'm going to promote is that you start with striving's patient zero, the very first striving self. You have to explain how mattering could ever emerge from matter, how you ever get from chemistry to even the most basic striving self. And if you do that, you get to reveal the bare essentials without all of the bells and whistles that accumulate through evolutionary history. You start simple. That is not how we tend to do it. We tend to do it through cognitive science, which starts way too high up. It's like trying to explain hair from quills, porcupine quills. They are hair. Consciousness is it's very much a striving self's property, just like quills are like hair, but it's very specialized and it's highly evolved. And it's also a little bit, cognitive science, like trying to explain striving starting with wigs, which is an artifact, a computer as an artifact by which we can try to determine what it is about us that is striving. You probably heard of the hard problem in consciousness studies, which is how do you ever get qualia, the experience, the feeling, the sensation of things. But cognitive science works from a computational model for what living is. So I consider it the made harder problem. If you're going to try to go from computation, which is not striving to do anything, and go straight to qualia, you're going to have problems. That's why I suggest we start with patient zero, that is, with the very first possible striving self. And I'll say this is a question behind our biggest questions, to reckon with consciousness, mind, qualia, free will, morality, mortality, spirituality, astrobiology, etc. Start by explaining how the first striving self could emerge from chemistry. So here's the mystery laid out. We've got names. We've got names for what selves are, for their properties, for their behaviors. We've got nouns and adjectives and verbs. And they all remain as yet unexplained by these terms from the physical sciences. So you could call us organisms, subjects, agents, individuals, living beings, creatures. You can even call us spirits or souls. It doesn't actually matter what we call them. These are names that flag what has yet to be explained. They just are markers that we use to say this is something we have yet to explain. And you've got all of these properties and all of these behaviors as yet unexplained in the physical sciences. Saying that you're a striving self is no more a scientific explanation than saying you have a soul. Both of them are just markers. So naming is not explaining. Here are some solutions that we often move towards since we have this gap and it goes unexplained. And I'm going to suggest that they don't work. Natural selection. There's an idea out there that the universe was rolling along with its natural laws, and then suddenly a new one enters called natural selection, and suddenly it gives rise to organisms. Doesn't work. Natural selection is actually natural degeneration. It's selves failing to self-regenerate. It explains the honing, not what's honed. To say that natural selection explains life is like saying that erosion explains mountains. Yeah, it explains how they're sculpted, but not what they are. So I want to say natural selection doesn't start life. Life starts natural selection. You actually have to have striving selves before you have evolution, as we think of it. Another idea is molecular replication, in particular RNA molecules, because they are so important to us organisms now. But the idea is that you would get molecular replication. What you've got here are examples of molecules not being created from scratch. It's conservation of matter. It's transforming of molecules. So you get these molecules going through their chemical reactions, but the chemical reactions can appear to strive, but then so can anything. A river can look like it's striving to get to the sea. And actually, chemical reactions like that are just going with the flow. So this idea that molecular replication somehow solves the problem will not do. And energy gradients degenerate first. They peter out. You saw that in these two examples I just gave you. But the material order can remain degenerating more slowly, still not striving selves. How about genes? Genes sometimes is used for the molecules themselves, as if a DNA molecule is a gene, but mostly what we mean by it is the sequences within the genes. Sequences are not striving selves, but interpreted by them. DNA, if you lay it on a table, is lifeless. So to argue that it's the secret of life seems to be missing something. It's not this magical molecule as it's sometimes depicted, the secret to life. It's a little like saying that text, which is also a sequence, is striving to tell you something. Another striving self is telling you something with their text, but the text itself is not actually striving to tell you anything. Or the alternative, which is that it's just cause and effect relationships, as if the sequence, the genetic code, which yields a one-to-one correspondence, a code is a material cause and effect process, is somehow all there is, which is another popular notion about it. I want to be clear on this. One of the places where we get messed up on this in the sciences and also in philosophy is to treat it all as causality. Interpretation is not causality. A stop sign doesn't cause you to stop unless you crash into it. We stop because we interpret it, given our strivings, as about traffic for our benefit. So interpretation is radically different from cause and effect. Complexity. Reason I have a frog on the cover of my book is that in the book I pose the question, which is more complex, a frog or a frog smoothie? Now technically, a frog smoothie is more complex. There's poor correlation. There's almost no correlation between the molecules once they're all shaken up, once they've degenerated, with a blender, but also they would degenerate anyway. That's actually more complex than the frog. The frog has more regularities. It would be easier to describe, which is the metric for complexity. So we often get ambiguous with this. Is it more complex or just harder to explain? The frog is harder to explain and yet less complex. It's its regularizations. It's the orderliness within a frog that is so impressive and so hard to explain. How about AI? Not striving, but engineer trained to aid our striving. If you connected a jillion AI supercomputers on a sterile planet, what do you get? You get a sterile planet. That is, no quantity of AI by itself is going to yield you striving selves. Quantum mechanics, quantum phenomena doesn't strive. Striving selves persist at the classical non-quantum level. Like jilted lovers, many researchers would rather not discuss it. They dance around the gap by equivocation, basically talking out both sides of their mouths. I read these glorious books by your neighbor, for example, Robert Sapolsky, who wrote this wonderful book called Behave, all about the biochemistry of motivation. I love these books, and yet they are still dodging the question. He'll talk about how a molecule causes a motivation. It's not clear how that happens, and he doesn't seem to be addressing it. You get a book like Information, a theory, a history, a theory of flood by James Gleick. Wonderful book, which by the end of it claims that there's information everywhere and has always been, by the end of the middle section. And then he goes into the last section about how we're now experiencing a flood of information. Which is it? Is it always everywhere, or is it something we can experience a flood of? If we experience a flood of it, then apparently we are interpreting it in a different way than we used to. But to claim that it's all information is a kind of equivocation. So information can be talked about as though it's just Shannon reductions in possibilities, or as a difference that makes a difference for a self that is striving to stay alive, to regenerate. So that's the question. And I want to hear your challenges to it. I want to hear you really kick the tires on this, really push back if you have trouble with the question, or if I haven't been clear about the question, and then I'll go on to a new proposed answer. No, intentionality would be a subset of striving. The words get really squirrely in here. That is, they carry a lot of baggage. In my last presentation at a biosemiotics conference, I called it trying, which tends to imply a kind of a psychological intention, a will, a conscious effort. So I've ended up gravitating to striving because, for two reasons. One, it's fairly clean on this question of ghost and machine. There's a tendency in this research to, I think of it like walking a tightrope line, this question here. Because you can fall off into ghost, basically homuncular, that is, you're anthropomorphizing what goes on, or into machine, mechanics, cause and effect. So how you ride that is difficult with the words we've got. There are definitions of intentionality that would be broad enough that would cover what all living beings do. But that's not the vernacular use of it. We usually think of it as something willed by a conscious feeling being. But yes, it is included in here. And by the way, I am not just striving to regenerate. I'm striving, for example, to communicate an idea. That is, by now, humans have all sorts of headroom and all sorts of distractions, other kinds of intentions. But if you want to get at patient zero, you start with the most basic, which is pushing against this tendency to fall apart.
So you mentioned artificial intelligence and the limitations thereof, that you could hook up a large number of artificial intelligence machines and that you would still not get a striving self out of it.
Nicely put.
One of the ways that we understand artificial intelligence today is just a whole bunch of linear algebra and neural networks, and that is very much a calculator. Are you saying by that artificial intelligence of today could not be a construct of that, or could it be never
No,
that?
I'm actually saying of today, and this is an important point. It's actually my takeaway. That is, once you understand patient zero, you have a new angle on AI, which I wouldn't know about because I'm not an expert on it, but I do think there's potential for it. And there's someone in the audience who's paying close attention to that potential. Anton, right here. There we go. Yes.
Thank you.
Yes. It's just not yet.
So are you counting viruses as striving or not?
It's a great question, and I would say yes, but to do that, I can't just work from impressions. I have to give an argument for that. It's a difficult argument and debatable. It's not altogether clear. The model I will give you for patient zero is like a non-parasitic virus. Without DNA, it's really got to be simple, and yet not impressionistic to do it. So it's, but yes, there is something about them that does seem, we talk this back and forth, me and this guy, and colleagues, including John and Anton. We explore this and wonder about whether viruses count or not, but we think they probably do. Yes?
So regarding your slide on genes,
yes.
How would you respond to the idea that a chicken is an egg's way of making another egg, and that it's not the DNA that is the striving self, but rather the coupled system between a ribosome and the RNA?
Well, even still, if you put ribosome and RNA naked on a table, they're not going to be a striving self. So there's but you're onto something. One of the things that life has to do is it has to replicate. And it has to reproduce. I use reproduce rather than replicate because replicate is the kind of thing you can do without paying attention to the work involved. You know, those chemicals were replicating, in effect, over there. No, reproducing takes work, so we have to explain the work that selves do. You know, we go back and forth between saying, I have this body and I am this body. I'm going to argue that what I am isn't my body. The body remains there after I'm dead. It's still all right there. The energy, the material, the organization, and yet I'm gone. So I have to be able to explain that and not resort to phantoms, not resort to ghosts. This is the challenge. This is what I'm going to try to do in this next little bit. But yes, you take a sequence or you take a coding process extracted from biology. It's not the striving self either. You just got to keep on. It's a process of elimination saying, well, and that's basically what I was going through with those solutions that don't. Each of those have been tempting, and I'm arguing each of those don't cut it.
Okay, so let's say you have a very simple organism like a non-parasitic virus that you mentioned, which is striving. Now, if we could simulate that with sufficient fidelity, would the simulation then be striving?
I'm delighted you bring that up. I want to propose a contrast between simulation and emulation. Simulation is done with cause and effect, formalisms, schematics, that sort of thing, basically arrows and pointers, you know, moving from node to node, by my version of it. That is, you are modeling the consequences of some behavior. Emulating would be actually showing how the behavior works. and it's different from modeling it. And I'm going to give you an example. The slide, two slides after this is going to be Anton's emulation of the process I'm describing. If you can emulate it, yes, you're well along to being able to understand it, but you have to work with the world as it is, and it's not a bunch of cause and effect arrows and nodes where you get to label the node and just talk about them as pointing this way. I'll be saying a little bit more about this. Emulation, I'm going to argue, is something different and totally achievable at Google. So that's one of the reasons why I'm interested in presenting here.
Okay, I mean, well, we'll see, but I don't completely buy the difference between simulation and emulation. It seems like a
good. And I haven't really delivered on it yet. So let me see what, I look forward to your questions and challenges after.
Okay.
Okay?
Thanks.
Okay, so this is Terence Deacon. I had met him shortly after this book had come out, The Symbolic Species. He spent 20 years as a neuroscientist at Harvard trying to understand the emergence and consequences of us having language, the symbolic species. And he had just moved on to another question, which culminated in this book in 2011 called Incomplete Nature, How Mind Emerges from Matter. Famously a challenging book to read, difficult to read. So my effort is to distill it and some of this into my book. I think of him as a natural philosopher, which is what scientists were originally called. He's a scientist. And yet he's dealing with philosophical questions, questions that scientists often don't get around to, like what is a striving self, or how does language actually emerge. He's also a very easy person to talk to. We have a meeting at his house every couple of weeks, open to whoever is interested. That's how Anton got involved. No, Anton actually read Incomplete Nature and decided he wanted to model or emulate the process that he proposes in here. John also joined up through that meeting. We just get together and explore this stuff. It's delightful, it's easy, it's apolitical. The guy's never pulled rank on me in 21 years. We just talk, we work on the problems. It's a delight. So here's the question as I posed it before. Striving selves are something different from nothing but chemistry. What? Starting with patient zero. And here I'm going to give you a grotesquely simplified solution. It's a chain reaction that generates chain reaction seeds. I'm not sure that Terry would like that, but it gets at it. And here is Anton's beginnings of the emulation of it. That is, he's imagining a chain reaction. He's modeling a chain reaction with all of the stochastics involved, and these seeds forming along the way. They are color-coded to represent their, in effect, viability. And this is very early days for this research, but he sees this as a possibility. For how we can get at the narrowing in on the kinds of molecules that might have made this process possible. You'll notice that I said that these were something like non-parasitic viruses, but there's no DNA in these things. The reading of sequences in the service of your striving is not the kind of thing you can imagine easily coming about spontaneously out of chemistry. It's a very complicated process. Terry has a model for how we could get there, but we're starting simpler than that. And as I said, simple but not impressionistic. Okay, now let me back up and tell you how I got there, how we get there. To your to-don'ts, basically your experience of life. You focus rather than dithering. You could have done dozens of other things right now during your hour here, but you chose to be here. And you're not just everywhere. You're doing focused work. Your focus is a product of self-control, everything you prevent yourself from doing consciously and unconsciously. And above all, you focus on preventing the degeneration of your ability to focus. So I'm going to be arguing that you are a prevention that prevents itself from ending. It's a process of elimination logic, very different from the arrow kind of logic we use in schematics and formalizations. And it's the insight behind a lot of very big breakthroughs. Pay attention to what's eliminated. Darwin, natural selection. To explain fitness, attend to the non-survival of the unfit. Shannon, signal theory. To explain signals sent, attend to signals not sent. Ashby, H. Ross Ashby, who coined the term self-organization. To explain increased order, attend to emergent constraint on disorder. I'm going to have to say more about emergent constraint. Here are two quotes from him that I like a lot. A self-organizing system spontaneously reduces the number of its potential states. observe what might have happened but did not. Here's an example, an intuitive example of it, threading through a crowd and others threading around you. You'll get these streams of people who are taking the path of least resistance that emerge by a process of path elimination. Now, these are striving selves, so it doesn't really count if we want to look for patient zero, but there are, of course, plenty of non-living self-organization processes. Now, the term self-organization is problematic. We were talking a minute ago about problematic terms like intention. It suggests a self trying to organize it, and there are plenty of people who have moved in that direction, talking as though if you just get self-organization going and it gets complicated enough, then you've got a striving self. I actually call it emergent regularization. It's a constraint process. And whirlpools are an example. Auto-assembly, like crystal formation, and autocatalysis, about which I'll say more now because they're essential to our model. Auto-assembly is basically crystal formation, but all sorts of other processes as well. Lipid membranes, for example, which are bubbles, or capsids, which will be crucial here. They're like viral shells. They're not actually constructed deliberately. They're not part of the striving process. They actually fall together just like crystals do. They fall to resting states. And the resting states, given their complementary molecular geometry, will yield you regularized sheets, shells, and tubes. So these are very exciting. Remember, we're trying to figure out how to explain the frog. Well, the frog is full of regularities, so we might look to this process, autoassembly, as a step towards life, towards striving selves. Autocatalysis is basically a chain reaction that grows a population of multiple catalysts that are all, in effect, producing each other. It's a population explosion that grows, depletes the resources that it depends upon, and then dissipates. So if you imagine you've got these two molecules, X and Y, and in this super simplification of it, they are both transforming reactants. I didn't get specific about the reactants, into more of each other. An X transforms an R into a Y, and a Y transforms an R into an X, and you get this population explosion of X's and Y's, but in the meantime, you're depleting all the R's, and you end up with a dissipation of the molecules. And the thing about this autocatalysis is it's more likely to start if you've got a cluster of the X's and Y's to start it. Yes, it could start with one X producing one Y, that then produces another X, but it's way more likely to start if you've got a cluster of them in close range. And often with byproducts, for example, an X might split an R into a Y and some other molecule, which will also be crucial to this explanation. Self-organization. So like I said, some people think that self-organization is enough. It's a variation on the complexity argument. If you get enough of this kind of emergent regularization, self-organization, suddenly it becomes a striving self. We don't think so. It goes with the flow towards overall degeneration, and selves don't. They strive to regenerate. But still, this concept of emergent constraint, that is reduced possibilities emerging throughout a dynamic process, is of interest to us. And we think there's a way to get at the origin, the patient zero of striving selves through it. So just to be clear on the general principle, the whole is less than the sum of its parts possibilities. Any of those people threading their way through the crowd could have moved in a whole lot more directions, but those directions are reduced through the congestion, and they end up taking paths of least resistance. As some probabilities become less likely, others become more likely. What's presented is a product of what's prevented. And so we got that throughout. Darwin, Shannon, Ashby are all playing with this key insight. And basically what we're doing is applying it to this question, what is a striving self? If it's not your body, if it's not your DNA and ribosomes, what is it? So we think of self-regeneration as possibly a higher level emergent constraint. So we've come up with a testable hypothesis for how coupled self-organizing processes could prevent each other from ending. And like I've said, it has to be simple and yet not impressionistic. I don't get to say, well, it looks like it's striving. It actually has to be doing work on its own behalf, fit to its own environment. Requirements for self-generation, very basic. If you think about, okay, everything's degenerating, how would you keep yourself from degenerating? You'd need self-repair, regenerating whatever degenerates. You'd need self-protection, that is preventing degeneration. And you need self-reproduction because eventually you will degenerate and you need lineages of self-regenerating, striving selves that have the capacity to self-repair and self-protect. And out of these three, you end up with this interesting challenge, what I'll call selective interaction. We all deal with it, but it had to be there at the beginning of life. That is, in order to do any of this generative work, you need to take in energy and resources and put out waste products. And at the same time, to prevent degeneration, you have to not do that. So you've got this going on from the origins of life. And that's a challenge for origins of life research because the kinds of selective membranes that we all rely on that let in some stuff and not others, pores and orifices and all that, you're not going to get that by chance, just a lucky chance that lets in all the right stuff, lets out all the right stuff, doesn't let in all the wrong stuff, doesn't let in all the wrong stuff. That is, a origins of life theory, an origins of striving selves, has to be striving successfully, outpacing the tendency to degenerate from day one. That it has to be able to do that. And this is a challenge, the selective interaction. And by the way, you're still doing all of this, obviously, self-repair. You're striving to keep fit and healthy, sometimes consciously, sometimes not consciously. Self-protection, you're regenerating skin, staying clothed with a roof over your head. Self-reproduction, kids maybe. And selective interaction, which has gotten very elaborate for human beings. There's a little taste of it in this room right now. I'm suggesting something that you can either absorb or avoid. People do all the time. We're always trying to figure out what to take in and what not to take in at many levels. From, you could say, the immune system to our mouths, all of this. All of it's still going on. So, here finally is that model that we showed, that I mentioned early on, and we got the emulation of it from Anton. Here it is, the Autogen, meaning the self-regenerator. Imagine you got one of those chain reaction processes, the autocatalysis, but its byproduct happens to be one of those capsid molecules. So while it's chain reacting, in the midst of that chain reaction, it's putting out molecules that will form the equivalent of virus shells. Not trying to form them, they just form, they fall together. That's the auto-assembly. So you've got a complementarity between the two, where you get a chain reaction, and then you've got these shells that encapsulate what I call starter kits or seeds, that if they break open in the presence of more reactants, can resume the autocatalysis, the chain reaction, and resume producing seeds. Okay, so let's take a look at this. You got the reactants, you've got a cluster of these catalysts in here. The purple molecules are the capsids. It breaks open. Let's say a big molecule hits it. And its guts spill out into the reactants, which generates a whole lot more C's, X's, and Y's that end up, by happenstance, captured within more of these shells. That's the seeds, or starter kits. Very simple model. Is there self-regeneration? Well, it's repairing the seeds as they degenerate, and the capsids protect against degeneration. It generates varied and evolvable autogen lineages, and there's selective interaction, though not quite. It's not actually choosing when to be open and closed. I'll explain how we get there in a minute, but at least you have an alternation, and the alternation is crucial, given that one of the things it has to fit is in environments where reactants are only sometimes present. We think of this thing like a ratchet. It grows for a while, and then it locks down. And while it's locked down, it can survive in environments where there are no reactants. That's why it's useful to have seeds or starter kits that are enclosed and basically static at that point. So it's functional in that it self-repairs when broken for its own sake. Remember, here's a good place to not be thinking about intentionality. It's not trying to. It doesn't care. It's not conscious. It's not willing all of that. And yet we have to start at that level if we're really going to understand that. The self-repair benefits the lineage of autogens. It's fitted, as I've mentioned. It's striving when seeds are broken, autogens respond with autocatalytic work that regenerates seeds. Here's an example of how it might evolve. We argue that at this point you have found a way to outpace the tendency towards degeneration. Breaks open, other molecules get into it. We have discovered a way in which it can self-purge. That is, it will tend to get rid of molecules that don't facilitate it. It breaks open, and the molecules that copy are the X's and Y's, not the other molecules that are kind of strays that enter into it. So there's a little bit of self-purging at this point. But imagine that you end up not with a Y, but a Z, And the Z happens to have a different byproduct, a different capsid molecule that's a little rougher on the outside, and the R's actually stick to it, making the overall seed rougher, more likely to break open. Now, this is the kind of thing we can emulate. I'm not saying this is the answer, but it does show the kinds of things that it could evolve, and it is an attempt to show how from nothing but physics and chemistry you could actually get a striving self that would then have the capacity to evolve. So when it breaks, you can see that this one actually begins to have selective interaction. It is more likely to open in the presence of reactants than in the absence of reactants. And then, as I mentioned earlier, we have a model for how you'd end up with a template molecule, a molecule like DNA or RNA, that has a sequence that is actually functional for the striving self. But we would argue, given the complexity of making use of a sequence, you really have to start with striving selves if you're going to get to the level where you can actually use DNA or RNA. Okay, so what's a striving self? It's not a ghost. It's not something added to chemistry. It's not mechanism. It's not the material, energy, cause and effect, work, or organization. It's a self-regenerative emergent constraint, a synergistic coupling between two self-organization processes that prevent each other's degeneration. What is the self then? What is a striving self? If you were to work all the way up to all of us, I would argue that we are a constraint that channels energy into work that prevents the constraint's degeneration. And that it came about through a synergy between two self-organizing processes that prevent each other from ending. Your whole is less than the sum of your parts' independent possibilities. So I come back to emergent constraints because I think it may have the most application in thinking here about how to move AI and other technologies beyond where we already are, to really push it. Observe what might have happened but did not. Emergent regularization, as I said, self-organization, is go with the flow, local, temporary generation of energetic and material regularities. Emergent self-regeneration, though, is selves striving against the flow to prevent their own degeneration. And it happens through this synergistic coupling where both of them stop the other from failing. Autocatalysis, remember, it grows and then dissipates. Well, the capsids keep it from losing all of its potential before it dissipates. And capsids will break open and dissipate as well. But the autogen replenishes the supply of capsid molecules, these molecules that form the shells. In general, though, there's a methodological question or proposition I want to make. Life isn't schematic or formal like our engineering and math simulations. It's running gauntlets, self-constraining possibilities to prevent dying. It's somehow figuring out how any organism does anything like this, running through the constraints because it is fitted to the constraints. It has internal to itself an agency that enables it to avoid all of the risks of degeneration. And in general, I find that across the fields, in philosophy, in programming, just across the fields, we're still using models that in one way or another apply point A to point B, kind of a Euclidean approach that I'm going to say is not quite how it works. Everything is random at the start, and somehow life figures out how to narrow in on possibilities. It's processes of elimination. Okay, so just these two takeaways. To push the tech envelope, pay attention to how tech simulates but doesn't yet emulate striving selves. And that's the thing we can talk about. And the other is to attempt to emulate, pay attention to emergent constraints, not schematic arrowing, but dynamic narrowing of possibilities. Thank you. Anybody have any questions and challenges?
So one of the interesting consequences of the way that you've presented this is that you mentioned it works on multiple levels, at the immune system level or the organization. Is there any bias in this for observing this at any particular level? Because you could look at it from an ant cell to an ant organism, as we understand it, to an ant colony, to the super colony that covers California,
yes,
versus humanity's cell or a person standing here or their neighborhood community society.
Yes, wonderful. Great question. The people who are doing this research come at it from a variety of different angles. My background's in the social sciences, and most of what I write is in the social sciences. And yet it's all under the influence of this model by now. I mean, the 1,000 articles I've written, they're all based on this. The political work, the moral work I do as a psychoproctologist, it's all based on this. In our own research, though, we keep focusing on patient zero. We are kind of obsessed at that level. And we also have people who come into the group with some intuition, some gut assumption that they want to uphold. They're kind of tethered to it, and they come to this work like it's a Rorschach blot, and they start to say, wow, this proves that I was right about this thing. I am delighted with how we managed to keep that from influencing the work. And a lot of this is because Terry is a nerd. He's dogged about this question. He wants to get it right. I've seen him change his mind lots. I've changed his minds about things, and he's way more advanced academically than me. He's not interested in the status questions. He's not interested in, I don't see in him any axe to grind. Yes, he would like life to continue striving, but no, I haven't seen that influence it. We've got some biologists in the group that are primarily interested in multicellularity. We've got all sorts of people who are interested in the implications of this narrowing, not arrowing approach to all levels of living systems. We've got a few guys who are really interested in whether organizations are organisms. And yeah, they can look like it, but are they really? So we have fussed about that a lot. I at one point was writing as though they were, that there were these superorganisms. And Terry laid out the challenges to that. Just because it gives that impression, it probably isn't. Let's look at what is the criteria by which you could say that something is actually a striving self as compared to an agglomeration of striving selves that are achieving things. So I love the way we employ the power of neutral thinking to the best of our abilities. And by the way, you cannot work in science without the possibility that you will have spent your entire life barking up the wrong tree. So I have no idea whether this is right, but I am enthusiastic about the way that it addresses a question freshly framed.
I feel a little bit like you've reduced kind of the original question to something which is a lot more tractable and I think is a less satisfying question. But for a bigger question, where does consciousness fit into this?
Well, Terry's a neuroscientist. He's got theories about there. They're hunches about how you'd actually get to qualia and consciousness. I just got back from the biannual Tucson conference on the science of consciousness. And it's remarkable how much they are talking as though everything is conscious, and then there's some kind of quantum leap. It crosses a threshold and then becomes conscious in ways we recognize. And you got people who are saying that there's no consciousness, and there's people who are talking about it coming out at the quantum level. All this sort of stuff. Very satisfying. I don't think realistic at all. So it's one of the questions that we deal with. You know, Terry having spent the first 20 years working on how language affects consciousness. I have hunches about consciousness being the really big difference, and I'm especially interested in how it changes adaptation. That is, life has been adapting for 3.8 billion years, and now we're doing it under the distorting influence of language, which makes us like these chronically hallucinating mammals, with all sorts of interesting consequences, positive and negative, and how to manage them it's a focus of another whole book of mine. But satisfying is a really key word here. Yes, in many ways, this has to be simpler. That is, you don't get any engineering. You don't have life already existing. And you don't get the delight of the impression that you have discovered how life as you experience it works. It's going to have to be a simple solution at this level. And yet I would argue that whether you buy this solution, this proposed answer to it or not, that's the level to work on it. Because if you cannot explain striving selves, you are not going to be able to get beyond explaining hair with wigs or quills. You're way up at the high levels and assuming away all sorts of stuff at the lower levels.
Is there a point at which awareness or awareness of awareness becomes significant or important to the definition?
Yeah, it's another area where we explore. We think that basically what we're describing here is what Terry calls vegetative sentience. I don't like the word sentience because it implies feeling. I like responsiveness. He and I have been working on how to find words that don't carry a bunch of baggage and yet nail it. So responsiveness. There's responsiveness from the get-go with these. If they break open, they respond by doing work to regenerate themselves, to repair themselves. Then there's feeling, which is more like sentience. And then there's conceptualizing. These are the three that are of greatest interest to us. And yes, there are a bunch of wonderful articles by Terry and colleagues about how it works at the higher levels. But again, for this presentation, I really want to concentrate on patient zero, because if we can't explain them, we're groping in the dark.
Not to get too morbid, but where does death fall into that cycle of regenerating and like those
Death?
capsules? Yeah.
Wonderful question. I am chronophobic, I am chronophilic. Death fascinates me. I memorize poems about it. Where does it fit into this model? What is dying when one of these breaks apart or opens in the presence of reactants? What's dying is not the material form. The material form can actually change over openings and closings. That is, several generations down the line, one of these seeds may have no molecules in continuity with the original one. And it's not the energy. The energy is coming from the outside. What is being lost is the constraint. When I die, my molecules are free to do way more things. Life is not an add-on to physics and chemistry. It's a subset. It's a self-constrained subset. That is me reducing the possibilities as long as I live. And as those, the synergies, by now through evolution, accumulated vast quantities of synergies, like the one we started with, the complementarity, where they both prevent each other from ending. We do that all the time in our bodies at so many different levels. It's a marvel. It's many PhDs. But what you lose is the constraint. And suddenly, the molecules are free. I read recently Dan Brown's new book on origins of life. And he tries to make that a pretty picture. Like as if everything is moving towards entropy, and that means that they're free, and that means that they're shining their light everywhere in the world. That is not how entropy works. Entropy is things falling apart, and if life was about maximizing entropy, which is also a popular notion in his book, Jeremy England brings this up, then let's just explode the sucker. I mean, if you want maximum entropy, there are faster ways to do it than we do it. We living beings. We actually sequester energy. That's one of the reasons why we've got petrochemicals. So the thing to pay attention to here, I was trying to get to it in the last 2 slides, is that what I am is a constraint on what happens. And when that constraint starts to fail, I lose my agency. And at that point, I'm dead, and the molecules are free to be in a whole lot more configurations. And often with offspring. In fact, my fellow grandfather of my grandchild is right here. Talk about offspring. This is my first time at Hecatech Mecca. I am delighted to be here. I'm grateful that you were able to give me your attention for this time, and do feel free to get in touch about any of this. If questions and challenges and kickings of the tire come to you tonight or anytime, I'm around, okay? Very local in Berkeley, and thank you very much.